let's talk about these two formulas, the differences between them and what everything represents, and I will go back and forth between the two. First of all, in this one, A, and in this one, P, this is going to be the original amount. Why is it A here and it's P here? Well, often in the context of this problem, it's the principal, which is the original amount. Whoops. I was about to give the wrong spelling of principal. Principal, like the person who runs your school. Okay, so that's the original amount. And you'll see what I mean when we get into the problems. Right now, we're just kind of talking about what is what. X in this case and T in this case is going to be the amount of time, the number of time periods. So the number of time periods, same here, number of time periods. So again, if you're looking at this and you're saying, well, that's odd. So like, why don't I use T on this one? Or why don't I use X on this one? This one's a little more graphable. This is what we're used to seeing as an exponential equation that we would graph. We've graphed ones like this. We've not graphed anything like this. So this is highly graphable. This is highly practical in terms of a word problem, but you can graph this if you wanted to. Call that a Y, call that a X, and you can put this in a word problem. So you're sort of seeing it in both contexts. Let's switch colors again. Let's go to purple. Y here and A here is the amount after time has elapsed. And same thing here. The amount, hence the A, after time has elapsed. And then the last one is this R right here. That's not in the other one. And this is the percent. It's the rate. And then I would say as a decimal, and I've worded it that way in the past, but it's not always been super clear. So we're going to do the percent, and then we're going to divide by 100. So again, it would be the percent represented as a decimal, although there might be a decimal in the percent. So for example, 6.5% is, move the decimal 2 places over, dividing by 100. Move it 2 places to the left, it'd be 0.065. Okay, so we have two formulas, and when do you use one, when do you use the other? I'm glad you asked. Oh, one more thing, plus or minus, you get to pick. We'll cross that context in a minute, but positive, I'm not going to write it because it's really obvious. Positive if the situation is increasing, negative if it's decreasing. So when do you use what? Well, notice that this one has a percent in it and this one doesn't. So for this context, percent is given. And in this case, a percent is not given. And I can write percent is not given, but they might give a growth factor or decay factor. I'm going to word it that way. Growth or decay factor is given. So if they give you a percent, you're going to use this one. If they give you a growth or decay factor, and you'll see a context where that makes sense. Right now it's kind of weird. Then that's where you use this one. So percent is given. You'll use this one. Oh, let's switch colors. And for this one, I had to run halfway across the room and get my orange highlighter. When they give you a growth or decay factor, like, oh, it doubles every 24 hours, that kind of thing, then you'll use this one right here. Those are the two equations we're going to use in these notes. Okay, right here, the B, what does it stand for? Well, the B doesn't stand for anything, but it is the growth or decay, depending on what it is, factor. There we go. So that's what the B is going to represent. So if I say it's doubling every time, that's a 2. If I have a third after each time period, then we're going to put a 1/3 here. If I say at the end of each day, then we have 5 times the amount, then a 5 goes right there.